So we'd like to look at the rest of the questions from the holiday break assignment. So let's get started here. So expression that's given in this way, what is that equal to? You see, the first thing is if you see a negative sign on the exponent, that means that either this one has to be a fraction, if you have to be denominator, it has to go into the numerator. In other words, this is in the wrong place. So if I have to assume that this is over 1, then this one has to go to the denominator. Then we're looking at choice number 2 or choice number 4. You see, the denominator of the exponent 3, that is in fact index of the radical. So therefore our answer will be choice 2, not 4. Here, in order for you to rationalize the denominator, we have to multiply by its conjugate, meaning look at the denominator and multiply by its conjugate, meaning plus 5. So I'm going to do that square root of 3 plus 5. Now then here we get, on the denominator we get 9 square root of 9 and plus 5 square root of 3 minus 5 square root of 3 minus 25. On the numerator we get 9 square root of 9 plus 5 square root of 3 plus 5 square root of 3 plus 25. It'll be awesome if you didn't have to do the one at a time, but I just did it just to show you what's going on. On the numerator we get this becomes 3, this becomes 25, therefore we get 28 altogether, plus 10 square root of 3 because 5 and 5, but the radicals doesn't add up. Here we get 3 and these two cancels out. 3 minus 25, which is negative 22. Since 2 is common in all of them, so we can rewrite it as 14, which is half of 28, plus 5 square root of 3 over negative 11. But this negative sign can go to the front of it if it needs to. So therefore, we're going to be getting our answer, which is choice number 1. Alright, how about here? We can square both sides, then we get x plus 3 will be equal to 9 minus 6x plus x squared. If you don't get this one from here, make sure you do the FOIL one more time and see if you get it. Negative x and minus 3, and here we get 0 equals x squared minus 7x and plus 6, and we know that this can be factored into x minus 6, x minus 1, hence x would have been equal to 6 over 1. Now let's try to check it out. If you have to plug in 6, square root of 6 plus 3, is that in fact equal to 3 minus 6? You see, on the left side, square root of 6 plus 3 becomes square root of 9, which is equal to 3, but on the right side we get negative 3. So 6 has to be rejected. How about 1? Square root of 1 plus 3, is that in fact equal to 3 minus 1? We get square root of 4, which is equal to 2, and that is correct. So 1 is our answer, which is choice 1. Number 28. Use the discriminant where this one will have an equal root. What does it mean by equal root? That means the discriminant b squared minus 4ac has to be equal to 0. What's the value of b? That's negative k. So we have negative k squared minus 4 times a. A equals 1 here because that's the coefficient of x squared. And c is equal to 4. Has to equal to 0. That means k squared minus 16 is equal to 0. Here we get k plus 4. We can factor that. K minus 4 is equal to 0. Hence k will be plus or minus 4. Any one of them would have been our answer. But in fact they are looking for all values, so plus or minus 4. Now find the sum and the product. So how do you find the sum? Sum is negative b over a. Then negative b value is equal to 11. A is equal to 5 here. So negative 11 over 5. How about the product? Product is c over a, which will be equal to negative 3 over a, which is equal to 5. And that's it. How about number 30? You see, in order for us to make this one into simplest radical form, since we have a square root, what we are looking for is a squares. So 3 times x squared times x. That's how else I can write down x cubed. Minus 2 times 27 is in fact 3 times 9, and 9 is good because it's a perfect square. Times x squared times x. Then as you can see here, x squared can come out, becomes x by itself. Here 9 can go out, becomes 3. And x squared can also go out. Then what we are left with is 5x square root of 3x minus, here 6 6x, because x squared came out, 6x minus, times square root of 3x. Then 5 out of those, 6 out of those, we get negative x square root of 3x. That's what we end up getting. Here we have a complex fraction. What do? We got to multiply top and bottom by common denominator, which is 2d here. Then let's multiply 2d onto the first fraction. Then 2 cancels out. We are left with d minus here. D cancels out, and then 4 times 2 becomes 8. That's what we end up getting on the numerator. On the denominator here, dd cancels out, becomes 1 times 2 becomes 2. And 2d cancels out, becomes 3. So we get d minus 8 over 5. That becomes our final answer. How about here? Since we have our index is 4, so everything has to be in terms of 4th power. 16 in fact is 2 to the 4th power times x squared times y to the 4th times y to the 3rd. That's how else I can make the 4th power. Now if you didn't know how to do 16 into 2 to the 4th power, you can do a factor tree, and you will realize that there are 4 2's. So this one can come out, and this one can come out, and the rest of them wouldn't be able to. So we have 2 2y 4th root of x squared y cubed. That's basically what we end up getting. But here when you look at the choices, everything has been written in fractional exponent format. So in other words, this becomes 16 and then x squared y to the 7th power whole thing to the 1 over 4th power. That's what it means by having 4 as index. Then we know that 16 to the 1/4 power will become 2. So we are looking at first or second choice. Now, then here we get 2. Between two exponents, we have to multiply them. So we get 2 to the 2 times 1/4 becomes what? 2 over 4. And y, 7 times 1/4 becomes 7 over 4. But once you combine them together, you will realize that that is in fact equal to choice 1. Here we're going to multiply top and bottom by its conjugate, so 5 minus square root of 13. Will be multiply top and bottom by 5 plus square root of 13, 5 plus square root of 13. Then here on the denominator we get, this will be the difference of squares, so we get 25, which is 5 squared minus 13, and 4 times 5 plus square root of 13. Then here we get 4 times 5 plus square root of 13 over here becomes 12. But 4 can cancel out here, becomes 3. So we have 5 plus square root of 13 over 3. That becomes our answer, which is choice 3. Here, how are we going to find the solution set? We have to square both sides first. Then we get 3x plus 16 is equal to x squared plus 4x plus 4. If you do the 4 correctly, then that's what you would be getting from here. Bring everything onto one side, 0 equals x squared plus x and minus 12. Then obviously we can factor this one. Here we have x plus 4, x minus 3. Then x must be equal to negative 4 or 3. But negative 4 wouldn't work because if you have to plug it in, on the right side you will get negative 2. On the other hand, left side you will get positive 2. So negative 4 wouldn't work. But please do check it. But 3 will work. So therefore our answer is choice 3. How about number 35? What is the product of this one and this triangle? Product basically means we need to multiply them. So here we get 1/2 y squared minus 1/3 y times 12y plus 3/5. Then first here we multiply 1/2 times 12 becomes 6 y to the 3rd power, and here we end up getting when you have a fraction times another fraction, then we multiply top and bottom by bottom, so we have plus 3/10 and then y squared. Third one here becomes 1/3 of 12 is 4, but it has to be negative because of the negative sign over here, and y times y becomes y squared. And then the last thing becomes negative 1/5 y. Now if you combine these two things together, then we get 6 y to the 3rd. Here we get minus 37/10 y squared minus 1/5 y. And that becomes our answer. Number 36. They want us to write a quadratic equation such that sum of the root is 6. If the sum is equal to 6, that means negative b over a is equal to 6. Now product is equal to negative 27. That means c over a is equal to negative 27. Here, if you assume a is equal to 1, then you get this one to be 6 equals negative b over 1, which is equal to negative b is equal to 6. But because of the negative sign, you will realize that b must be equal to negative 6. How about here, c? What if a equals 1? Then negative 27 would have been equal to simply c. And that's done. C is equal to negative 27. So quadratic equation would have been x squared from here minus 6x minus 27 equals to 0. That is a quadratic equation that satisfies the given condition. Number 37. Here, what is common? GCF, that's right. We can factor out 3t to the 4th power. Then what do we have left? 4, because out of 12, if you factor out 3, we are left with 4. Out of t to the 8th power, t to the 4th power can come out. That means t to the 4th power is left. And then from the right side, you will realize that that's equal to 25 here. Then 3, t to the 4th power. And here, 2t squared minus 5, which is the difference of square, 2t squared plus 5. And then there isn't anything else which we can do, so that's it. We want to use the positive exponent. Okay, then let us try to distribute everything onto here. So 3x to the negative 4th and y to the 5th. Over here, negative 2 is being distributed, so we have 2 to the negative 2 power, x to the 3rd, and y to the x to the 6. We gotta this should be negative 2. That means in fact negative 6 here, and y to the positive 14. Now, then by moving things around, we get here 3 times 2 squared, and then y to the x to the negative 4th has to go down, so we have x to the 4th, but x to the positive has come up, and here y to the 5th over y to the 14th. Then here we get 12. This becomes positive, so 6 minus 4 becomes x squared, and here 5 minus 14 becomes x to the negative 9. But or 12x squared over y to the 9th power y. That is our final answer. Alright, let's look at number 39. So how are we going to do this one? Here, if I were to divide it by negative 3, then we get 6 minus x of the absolute value is greater than 5. But within the absolute value, I can write it as 6 minus x or x minus 6 has to be greater than 5. That means from 6, the distance which we are looking at is 5, so I'm going to go up by 5, then I get 11. Go down by 5, then I get 1. But since I don't have the equal to sign, I'm going to have open circle in both cases. But the distance has to be greater than 5, that means greater, that means I have to go further outside. So that becomes our final answer. Alright, the last question. We want to solve this one algebraically. Then here, let us realize that 5 plus x equals y by adding x to both sides. Then we can put this one in place of x here. Then we get 4x squared equals negative 17x plus 5 plus x plus 4. Then when we bring everything onto one side to the left, we get 4x squared, which is equal to, plus 16x, because we had a negative 17x, we're adding x here, and then plus 9. Or in fact, it would be minus 9, because this one is plus 9, or coming over to the other side, negative 9 is equal to 0. Now, then what we want to do is, we want to see if this one can be factorable. Now, so if you can think of the mix right away, how we can get positive 16, then it'll be great. If not, we cannot do it, I guess. But we can factor this one as 2x and 2x. How about that? Equal to 0. And to get 16, we could have plus 9 and then negative 1. Then we get positive 18 and then negative 2. Hence become positive 16 in the middle. Here, then we get 2x minus 1 is equal to 0. That means 2x is equal to 1, where x equals 1/2. How about y value? The second one, 2x plus 9 is equal to 0. That gets you x equals negative 9 over 2. So we have two values. But since what we're looking for is x value and y value, when x equals 1/2, we can put that in this simple equation, 5 plus 1/2, that must be equal to y. In other words, that's simply 5.5, which is equal to 11 over 2. Second one is negative 9 over 2. That means 5 plus negative 9 over 2. That's equal to y. That means we get 1/2. So that is our final answer, and have a great day. Bye-bye.